Inheritance. Class inheritance. It's a new concept. Let's first read what Wikipedia has to say about this, and then I will try to explain it to you my way, and then we will code a few basic examples. In object-oriented programming, inheritance is the mechanism of basing an object or class upon another object, or a class. In Java it's class-based inheritance. Retaining similar implementation, also defined as new deriving new classes, subclasses, from existing one, a superclass or a base class, and forming them into a hierarchy of classes. In most class-based object-oriented languages, an object created through inheritance, a child class, acquires all the properties and behaviors of the parent, except constructors, destructors, etc., etc. Inheritance allows programmers to create classes that are built upon existing classes, to specify a new implementation while maintaining the same behaviors, to reuse code. And this is the key here. Reuse code. Well, that's a bit heavy, but once you will see what it is, this will be simple to understand. Basically, you have a class that does something, and you have a few other classes that needs to do the same thing, or have the same properties. So what do? You make them the child classes of the class with the behaviors you want. The class is the parent and they are the children classes, and they inherit all of its properties, methods, even the constructor. Even if it says here it does not inherit the constructors, it's depending on the programming language. In Java, the constructors is passed on. And let's say you have a child class that needs to behave a little bit differently. You can override a few of the parents' methods or attributes if they are public. If they are private, no, they are safe, they cannot be changed. If they are protected, they are visible to the parent class and to its children. And as it says here, the key thing here is to reuse code. It's a very, very, very powerful method. Powerful technique, powerful doctrine, whatever you want to call it. So here we have an empty main, and I also emptied the item class. In our example, we will have a warehouse. The warehouse will have items. Not all items are the same. We will have the parent item, which is a general item. It will have a name, it will have a position, and it will have an order method, or a take method. Like if you take it, you can take an item and you can order new items. So you have a lot of types of items. You have, let's say, books are a different category of items, and food items are a different category of items. Let's stick with that. An item class, a book class, a book item class, and a food item class. Both of the item and both of the book item and food item will inherit from the item class. It will inherit all of its functionality, methods and items alike. We will make them public so we can manipulate them, and you will see what everything does. Let's start. I said we'll have a public string name. Let's give it a tab. And it will have a few more attributes that are strings. Let's say we set position. Let's say for now it will be a string like row 3, column 1, ISBN something something. So whoever wants to take it will know the position. So you can pass it as text with letters and numbers and whatever. And we will have the quantity. Or, nah, let's not worry about that now. Let's do price. Every item has a price. Yeah, you can add quantity and all that. Let's make the price an int. The price is usually a float, but let's say it's a fixed price or a rounded price. It can be something like a 2.5, 3.5. It's like, let's say it can be 2, 3, 4. It's fixed priced. And let's create a constructor like lazy people. Let's put the cursor here and go to source in Eclipse, if you remember, and we will generate a constructor using fields like lazy people. And here they are all ticked, and you know, the name, position, price, whatever. Yeah, we don't need the super here. And yeah, I told you never give anything the same name, so we will add 2 to everything. And we don't need the this. Maybe in an older version of Java you would need the this, but not here. Okay, we said we wanted 2 public methods. Public void, the methods won't return anything. We don't want them to return anything. Public void order I always want to know where it ends. And the other one will be take. And here we will just print out stuff. We are not going to code any logic or anything. For that you will need to code, if you will have a project like this you will have to code it yourself, but here it's just an example, so we can just output stuff. Order item. Just so we'll see in the console what happens when the method is called. It can be done with a few lines of code, with 100 lines of code, but we don't care. We just output what happens, not anything. Take item, and that's it. Now we have a class. It has 3 attributes, and it has a constructor that assigns values to these attributes. We can make them even private attributes, it doesn't matter, because we can assign them for the constructor, but let's leave them public so we can also access them if needs be. And we have a public order. I'm using public just to simplify things. I don't want to complicate it with visibility. Maybe in a future tutorial, maybe in a future project in this course you will see a more practical example, but I just want to show you the concepts as of now. So we have those 2 methods, we have the constructor and attributes, and let's click the package L33, and let's click here for a new class, and let's call it item book item. Okay, let's save the item, and the inside book item we will leave it empty, and let's create another class and call it food item. And to make them inherit item, we will just have to add in the public class after the class name, we will have to write extends and the name of the class we want to inherit from, which is item. What is that? Add a constructor. Yeah, let's add a constructor. This gives it a constructor that sends it to the super constructor. All of this will be sent here to this constructor in item. That's it. That's what super does. It sends stuff to the parent method or constructor, and it does what this constructor do, which is assign values to the attributes, and then continues execution. Let's copy this, extends item, and we will need to add another constructor for this. Because it's Eclipse, it's easy. I just hover it and I click add constructor. And that's it. It adds the constructor I need from the superclass with all the arguments that needs to be passed, etc., etc. So let's create an item, a generic item I equals new item, an item instance object, and let's see I.order. Oh, I need to give it attributes. The name, the position, price. The name will be none, and the position will be A3 Z4, whatever, and the price will be 0. So I'll say order. Invoke the order method. Let's see if it works. Order item. Now let's create a book item. Call it B equals new book item, and now we also need to give it attributes, like let's give it a name, Harry Potter. And I need to give it a position, Hogwarts, with intentional, oh, and the price will be 100. Intentional spelling. And let's use also order. Let's change it to B, so it will call the order from B. And it will print order item twice. But wait, book item doesn't have an order method. Where did it came from? It came from the parent class. It inherited the method from the parent class. Let's do it with the food item. It will be burger, and its position will be C4B, something random, and price will be 5. And let's use f.take. Now you will see we'll have take item. But wait, food item doesn't have a take method. Where did it came from? Because it extends item, it can use all of the attributes, all of the constructors, and all of the methods of item. So as you can see, we have a simple but powerful template here for our code. It's very good. We can have a lot of methods inherited from the same base class, parent class, like item, and it will already have the functionality we need or want, or whatever. And let's say we want to, let's say we had the take method here and here, and in 10 more classes, and we wanted to change it from take item to take item and its name. We will have to go to each class and change it. This is crazy. But because they inherit from item, and the method is in a single place, it's inside of the item class, we can change it here in one place, and this method will be changed throughout all of its children implementations, or the children that inherit from item. Let's do this actually. Let's have a space here and let's take item and plus the item name. Let's see, it will write take item burger. Great, let's do it for the order item too. So we'll see the item's name. Order item known and order item Harry Potter. Awesome. That's great. We've just used these two methods. We use them in two different classes without needing to re-implement them or write them again. Right in one place, using all the children classes. And remember, in Java, you can only inherit from one class. You can only have one parent. Let's see in Wikipedia. Here, B inherits from A. But in different programming languages, you can have C that inherits from A and B. In Java, you can't do this. Well, you can cheat, but in the regular syntax, in the base syntax of Java, you don't have multiple inheritance. So you can inherit from one class only. In our case, it's item. So let's see. What else do we want to do? I also would like to show you how to override stuff. Let's say to order a food item, you need you need to do more stuff like get a permit from the health department. So this order will do nothing. But if we wanted to have the same stuff that the parent order does, we will need to use super. What super does, in this case, what's the problem here? Super.order. So what this does here is call the super, which is the parent class, and call the original order method this order method. This is the super class, the parent class item, and this is the overwritten food item order method. We overwrite it. We can not use the super class, but I want to show you how to use it. Let's do more stuff. .o and health permit. So now it will print this, and it will also print this, but only for food items. Let's see. Let's order a food item now. Let's change the B to an F. You will see. Order item burger with a health permit. Let's add the name. Just so we'll see health permit for burger. So we got the order the burger, and we also health permit for burger. We can also add other stuff here if we want to extend the order method upon the super order method, which is here. we can also change the parent order method so it will affect all of the children of item, all of the other items, including book and item and whatever other items categories we have in the warehouse, in the imaginary warehouse. And let's say taking an item, you need a special permit. So here we can add some kind of validation to check that the user has a permit to take the item. And this will affect all items because it's the parent class. Or let's say you had a special item, like you need a special permit to get a book. We will need to override the take method inside of book and have some kind of code that will allow some users the permit to use the take method. This is how flexible this is how modular it is. And let's see. So let's cover it. Let's cover it again. The item class. It has 3 attributes: name, position, price. It has a constructor that sets these attributes from the arguments the constructor gets. Let me show you. Here is the item. And here are the arguments the constructor gets. And it has 2 methods, public methods, order and take. Now, book item class extends item, so it inherits everything from it. It inherits the constructor via the super keyword. We can pass the attributes it gets from its own constructor to the super constructor. It also inherits the 3 attributes. And the super constructor, this constructor, will set them from the argument that book sends it. Also, even if it's not written here, book will have access to order and take methods. Food item has the same thing, but food items for food item we decided to override and the order method, but leave the super order method, this method, intact, so we can use its functionality, which in our case is just printing stuff. And then we add our own functionality, which is add a health permit for the item plus name. Let's say for some reason we wanted the order to be without the item name. We can delete this, and now all the ordered item won't have a name. When you use the order methods, it won't say order item and its name. It will just say order item. If we do something like this, here, let me show you. Order item, order item, order item, without the name. Let's return it. And let's run it again. Order item known, Harry Potter, and order burger. And that's kind of it. Again, I do not expect you to master it in a second. I do not even expect you to fully understand it. I didn't understand inheritance and object-oriented programming when I started. You can use other resources. You can rewatch this video, or you can wait for future lessons that will show more practical examples, so you understand it better. For this, I just wanted to show you the syntax, so you will get familiarized with it. You know how to initialize and create an instance of an item and use its constructor. You know how to create a constructor. You know what attributes does. You know how to create methods and use them, like we do here. And now, you know how to use inheritance too, and how to use a super constructor, and how to extend or override a parent's public method. And that's it for this lesson. If you have any problems or questions, please contact me via the Q&A. And that's it.